Today we are going to be learning about surface areas of prisms, and the second lesson we're going to learn is about the surface area of pyramids. But right now with the surface area of prisms, first of all, what is a prism? Well, a prism comes from a family of solids with flat faces. And a solid with flat faces is called a polyhedra. Polyhedra means many faces. So that's what a polyhedra is. It's many faces. Now, what is a polyhedra? Well, all of these are polyhedras. These are just some of the polyhedras in the world. This one right here, this is a polyhedra, but that's called the pyramid. We're going to talk about why it's a pyramid later. This guy right here, that's called the prism. In particular, it's a cube. Okay? All of these are polyhedras. Not all of them are prisms. Not all of them are pyramids. But they're all polyhedras. They're solids with flat faces. So all of these are polyhedras. Just wanted to give you an example of what you're looking at. What is it that we're learning about? Yes? Yes, sir. All of these have flat faces. Yes, sir? Okay, second one from right to left. This guy? Right here? Those are all flat faces. Absolutely. When you look at the video later, you'll see where I'm pointing. That's a triangle. 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 That's a square. That's a hexagon. That's a square. That's a hexagon. That's a square. That's a triangle. That's a triangle. It's made up, I promise you, of flat-faced little polygons. Okay, yes, sir. Kind of like a soccer ball. You ever notice that a soccer ball has the pattern of pentagons? Right? Is it pentagons or hexagons on the soccer ball? Hexagons. Well, that soccer ball is the best example of a polyhedra because you really know what it's like. Okay, and it's round, but the faces are flat of the soccer ball. Yes. Okay, the question was to get the area of that. You have to get the area of all the triangles and squares. That's exactly right, but let me get to it. That's called surface area. Yes, sir.
Theoretically, they has infinite angles. Why isn't it a sphere on there?
Okay, the question was, why isn't a sphere on there? Because a sphere is not made of flat faces. A sphere is a circular figure. Okay, so these are polyhedras. They are made up of flat faces. Okay, now let's talk about some specific information about these polyhedras. One familiar type of polyhedra is called a prism. Okay. The prism. Okay? The prism. Every prism has two congruent parallel faces. And those two congruent parallel faces are called bases. And a set of parallel edges that connect corresponding vertices to the parallel faces. I'm going to explain all of this in figures now. The parallel edges joining the vertices of the bases are called lateral edges. The faces of the prism that are not the bases are called lateral faces. The lateral faces of all prisms are parallelograms. Therefore, we name the prisms by their bases. A prism with hexagonal bases, for example, is called a hexagonal prism. So, what am I talking about? These are prisms. And as you can tell by the names of these prisms, the names of the prisms are given by the base, the shape of the polygon that forms the base. Now, let's talk about some things here. This is the base. Why is that the base? Because the base of a prism is both top and bottom. Okay, they're opposite sides, they're congruent, in the same polygon. So this is a rectangular prism because the bases are rectangles. This is a hexagonal prism because The bases are hexagons. Both of these bases are hexagons, and they're both congruent. This is called a pentagonal prism. It's called a pentagonal prism because the base is a pentagon. Okay, both bases are pentagons, and they're both congruent. Now, the lateral edge, which is in blue. Okay, so now let's talk about the lateral edges. The lateral edges are here in blue. These are the lateral edges. The lateral edges go from one vertex of the base to the next vertex of the base. So this is a lateral edge. 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 And then in green, the lateral face. Well, just color in between the two edges, and that's the face. Since this is a hexagonal prism, it's going to have 6 faces. The rectangular prism, let's just color green in between the lateral edges. Boom, that's my face. Let's color between the lateral edges, and that's my lateral face. So a prism is made up of 2 congruent bases. That's in the red. Okay, the red. Then you have the lateral edges, which are in blue. And then you have the lateral faces, which is in green. That is a prism. Okay? Now, in order to find the surface area, let's investigate what surface area really is. Surface area is the sum of all faces of the polyhedron. So the real technical way that they teach this is to break down the polyhedron that's given to you into what's called a net format. We are going to use a formula. So we are not going to do this. But I don't want to just give you a formula and you just plug in the formula blindly just on the faith that Mr. Morrow is correct. I don't want that. I want you to understand where this formula is coming from. So when I talk about a net, that's what I'm talking about. You have this rectangular prism up here. Okay? Think about breaking down a box. Okay? All of these numbers refer to all of the sides, or the faces rather. So let's first pop down the front of the box, okay, which is going to be this guy right here, the 6. If we keep popping down, we're going to get the top of the box. Yep. Then this is the front. Then this is the back. Then that's the side, and that's the side. There's 6 faces that a box creates. Yes? It really doesn't matter which one's the top or the bottom. It doesn't really matter, but no, when I'm folding this out, boom, this would be now this would be the top and the bottom, this will be my front and my back, and these 2 guys are the sides. Okay? But I don't really break things down into nets. I don't. I use a formula, which is much more efficient. But when in doubt, if you forget the formula, break your polyhedron, your prism, into a net, just like you have in front of you, and then find all 6 areas and add them together. Now, you can have a box like this. This is a triangular prism. Why is it a triangular prism? Because the bases are triangles. Very good. So pop off those 2, and boom, you got your 2 sides, or actually the bases. Then you have one side of it, the opposite side of it, and then the actual base. So again, I think this is inefficient. I don't teach it this way, but this is what surface area is all about. Surface area is the sum of the areas of all the faces of the polyhedron. Yes, sir? Is it possible to have a rhombus as a base? Absolutely. Absolutely. And I found one mistake here. Surface area is the sum of all face areas of the polyhedron. Okay. So now, that's what surface area is. Let me show you how to work with it efficiently. Surface area, my friends, of any prism, 2B plus LA, where B is the base area and LA is the lateral area. Two ways to find lateral area. You can add up all the areas of the lateral faces, and that will be your lateral area. Or, for prisms, and only prisms, the lateral area equals the perimeter of the base times the height of the figure, not the height of the base, but the height of the figure. So surface area of any polygon, of any prism is 2 times the base area plus the lateral area, which is the base perimeter times height. That is the formula. With this formula, you have replaced making the net for any prism and therefore saving lots of time. Yes, sir? I didn't say the height of the perimeter. This is the perimeter of the base times the height of the figure.
Yeah, for the height of the figure, you mean like...
I mean the height of the figure. For example, okay, I want to, A, find lateral area. Then I want to find total area. Okay, so let's do this. Let's first find lateral area. Lateral area equals base perimeter times the height of the figure. What is the base perimeter here? Okay, think about it, guys. It's 14 plus 13 plus 15. So I've got 42 times, what's the height of the figure? The height of the figure is from base to base. Think about it, guys. Picture a Coke can. Doesn't that have a circle on the top and the bottom? That's a prism. How tall is the Coke can? Isn't it the height from the bottom to the top? Well, what is the height of this prism? The height from the base to the top. That's the height. So, that's my lateral area times 20. So, it's going to be 840. Now, B, how do I find my total area or my surface area? Well, surface area is going to be 2 times base area. Base area is going to be 14 times 12 divided by 2, so that's going to be 84, plus lateral area, which we already found, of 840, and that's going to give me 168 plus 840, which gives me 1,008 units squared. Does that make sense? Does that make sense? Yes, sir. The question is, how do I get the P? It's the perimeter of the base. The base is this triangle, son. The perimeter is the sum of all sides. 14 plus 13 plus 15. Just because the 15 is over here, what is the definition of a prism? Both bases are congruent. So if this is 15, that means that this guy here is 15. So the perimeter of the base is 42. That makes sense. That makes sense for the height now of the figure. Okay, great. Thank you. Awesome. Let us continue. 12.2. Surface area now of pyramids. Now, a pyramid is also a polyhedron. It's made of many faces. But a pyramid has only one base. Its lateral edges are not parallel like in a prism, but they meet at a single point called the vertex. Sometimes they call the vertex the apex. Okay? The base may be any type of polygon, but the lateral faces will always be triangles. Pyramids are named by its bases. For example, these are all pyramids. This is called a rectangular pyramid because the base of the pyramid is a rectangle. The second one is called a hexagonal pyramid because the base of the pyramid is a hexagon. It's kind of hard for me to trace the heptagonal, but hepta means 7 sides. So it's a heptagonal pyramid, this guy, because the base is made up of a 7-side polygon called a heptagon. Decagonal pyramid, it's got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. It's got 10 sides. So since the base is a polygon with 10 sides, it's a decagon. That's a decagonal pyramid. So the difference between the pyramid and the base, again, pyramid has one base. And the prism has 2 bases that are congruent. Now, the way to find this surface area is also to break this down into a net. For example, for this rectangular pyramid, the way that most teachers teach it and the way most books teach it, okay, you get the base, then you pop out the front, the side, the top, or the back, and the other side. Then you find the area of all 5 of these figures. That is fine, but time-consuming, and it could lead to a lot of errors because you have a lot of calculations. Yes, sir? All the triangles are isosceles was the question. Yes, since, remember what the definition told you. The lateral edges are not parallel, but they're all the same height to reach the vertex. So yes, they are isosceles triangles, sir. Sometimes they're going to be equilateral, but they're isosceles. Yes, yes. All the triangles in this particular case is congruent because, actually no, they're not congruent. This is a rectangle. So if that's 10 and this is 5, this could be, for example, 16 and 16 for all of the heights. But this base is 8. This base is 10. So no, the triangles are not congruent. They're just isosceles. Let me continue teaching, and I will answer all of your questions. Let me continue teaching, and I will get to all of your questions. Because a regular pyramid is next on my list. A regular pyramid has a regular polygon as its base, and also has congruent lateral edges. Thus, the lateral faces in this case of the regular pyramid are congruent isosceles triangles. But that is only when the base is a regular polygon. Okay? Now, to show you how the pyramid works and all of its pieces, I have a couple figures here for you. I have a square pyramid and a hexagonal pyramid. I have 2 different pyramids just to show you that it's all the same nonsense. Okay? Of course, you have the base. Of course. Now, that's the base. The altitude. The altitude, as we know, is a vertical line that goes directly to the center of the base, creates a right angle, and it also cuts the base into perfect halves. It cuts the width into perfect half, and it cuts the length into perfect half. So that's called the altitude. Okay? And now, the slant height. The slant height is a height which creates a 90 here on this base, but it's the height of the face. It's not the height of the figure, it's the height of the face. And it is called a slant height. And as you can tell, everything is mimicked down here in the hexagonal pyramid. The only difference between the hexagonal pyramid and the square pyramid is the base. But you still have your altitude. Okay? You still have your slant height. And the slant height creates a 90 just like the altitude. And then I got one more for you. You have up here at the top, that's your vertex or your apex. Okay? The slant height, very clearly defined. Here's the slant height. Very clearly defined. The face. The face is this right here, the actual face. What's in between the lateral edges. This right here, that's the face. Lateral edge is this guy right here. And of course, the base is this bottom red part. That's the base. So those are the components of a pyramid. Now, let's get to work. Two formulas that I've created for you. Surface area of any pyramid, that's really false. It's not any pyramid. It's, no. I'm just going to put of a pyramid. It depends what type of pyramid we're dealing with. When the faces are the same, in other words, when I have a regular pyramid, okay? When I have a regular pyramid, this is the formula we're going to use. Surface area equals 1/2 of slant height times base perimeter plus base area. 1/2 of slant height times base perimeter plus base area. When the side face are different, okay? When the side faces are different, you're going to have surface area equals B, big B, which is base area, plus lateral area. Now, you cannot use the formula for lateral area of a prism. In this case, you are out of luck. I'm sorry. When you have a non-regular pyramid, you got to find the base area, and then you have to find each of the lateral face areas and add them together. And unfortunately, that's the only way that you can do it when the pyramid is not regular. I'm going to show you a couple examples, and you should be golden. And remember, this isn't just one formula for one thing. These two formulas will encapsulate every single pyramid ever, no matter what the base. You can find the surface area this way. So if we went to the pyramids of Giza in Egypt, we could find the surface area using this formula. Okay? It's pretty cool. Now you would not have to cut the pyramid. You wouldn't have to climb it either. When we do trigonometry, I'm going to show you by just looking at something and looking up or down, you can find the height by using angles. But we'll get to that in trigonometry. Okay, now, let's do some examples. Problem 1, given You have a regular pyramid. So what does regular pyramid mean? All the faces are congruent, and more importantly, though, the base is a regular polygon. Okay? So they want you to first find A, the lateral area, then B, the total area. Okay? Now, since it's lateral area, okay, I cannot use a formula for this, unfortunately. However, since all of the triangles are the same, all I have to do is find the area for one face and multiply it by 4. So before I can do that, I need to find the height of the face, don't I? Not the height of the figure, but the height of the face, which is called the slant height. Slant height is perpendicular bisector. We'll be right back. So let us continue here. So the lateral area here, okay, we have to find the slant height. Well, this slant height cuts the base in half, so that goes to 6. And I know that this edge here is 10. So I have right here a nice right triangle, and it's actually a 3, 4, 5 triangle, so the slant height is 8. So, lateral area for a pyramid. Remember, it's different for a prism. For a prism, lateral area is perimeter of the base times height. You're done. But for a pyramid, it's the sum of all lateral face areas. So this is going to be base times height divided by 2. So that's 48 times 4 equal triangles. Why are they equal? Because I have a regular base. It's going to be 192 square units. Does that make sense? Okay. Now, my total area. What did we say total area was? Okay. Now, do it 2 ways in this case. Surface area can equal 1/2 of the slant height times the perimeter of the base, which is 48, plus base area of 144. What does that give us? 336 units squared. Now, we use that formula because we already had the slant height and it was a regular pyramid. But we could have used the other formula since we already knew our lateral area. What is the area of the base here? 144. What's 144 plus the lateral area of 192? 336. So if you find a lateral area, whether it's a regular pyramid or not, if you have the lateral area already, just add that to the base area and you're done. Now, if they already give you the slant height and they give you the side, don't worry about finding the lateral area. Just go ahead and plug it into this formula if it's a regular pyramid. You with me? Now, let me show you what a non-regular pyramid is. And I think you'll like this. I animated this, so bear with me, okay? The base of a rectangular pyramid, ABCDE, is 10 by 18. The altitude is 12. The lateral edges are congruent. Okay, in this case, the lateral edges are congruent. Why is ABCD not a regular pyramid, though? It does not have a regular base. So that means that this side, even though this is congruent to that and congruent to that, is this triangle congruent to this triangle? No. So it's not regular because it doesn't have a regular polygonal base. Yes? Okay, now, let's go ahead and set this up. Now, the way you set this up, you have 18 as the width. You have 10 as the other side, as the length. Then you have an altitude, which is that blue line. Now that altitude is 12. That altitude creates a right angle, okay? Not only does it create a right angle, but it splits the sides in half. So making that now, instead of 10, 5 and 5. It also splits the width in half, the other side, making that 9 and 9. Then I have one slant height on the side of the 10, and I have the other slant height on the side of the 18. So it's very important for me to focus on how I set that up, because now I want to find the total area. Well, hold on. Why did it go? Why did that happen? Let's go. Oh, that's boo. All right, we'll do it again. We'll do it again. Let's see if that does. No, that doesn't do anything. No. It's got to go back to, okay, we'll see it again. We'll see it again. Pay attention to what's happening. When the bell rings, you are not dismissed. Give me 1 second. Okay, so please pay attention to what's happening. Okay, that altitude cuts that base into halves on both the length and the width side. So it's very important for you to understand that. And then you have to put the slant heights. Okay? The slant heights are really important. Okay. Now, let's figure out the total surface area. It's not the total surface R's. It's not the total surface R's, but it's the total surface areas. Okay, so let's do this and I'll let you get out of here. Okay, I have surface area equals the base area plus lateral area. The base area in this particular case is 18 times 10, which is 180. Very good. Now, not degrees, just 180. Now, please pay attention to this. The lateral area. Let's first look at this triangle here. Okay? My little green guy here is the slant height. Cuts that into 9, that into 9. Okay, but I have this here 12, and this is 5, so that's a 5, 12, 13. Very good. So my slant height of this face is 13. You with me? So the area of that face is going to be 18 times 13 divided by 2, right? So that's going to be 127, correct? So that's plus 117, but times 2. Why times 2? Because you have one on this side, but you have one behind it that's exactly equal. Now, let's get this triangle, okay? Now, this was 12. This is 9. So that's a 3, 4, 5 times 3. So that slant height is 15. So plus 10 times 15, which is 150, divided by 2 is, but times 2 of those triangles. And then this is going to give me in total 180 plus 150 plus 117 times 2. So what does that give me? What does that give me? 564 square units. So please be aware that you have to find the base area and then the lateral area for pyramids. Thank you very much. Have a great day, and God bless you. Bye-bye.